So this question is about Rutherford's alpha scattering experiment. So Rutherford's experiment, he had an alpha source. He was one of the pioneers of investigating what we now call nuclear physics and radioactivity. So radioactivity hasn't been known to exist for quite some time, and Rutherford's doing some experiments on it, and he gets Geiger and Marsden to do some experimental work on it. They put the alpha source, surround it with lead to collimate, to make the emitted alpha particles go pretty much in a beam. Then they had some very thin gold leaf. Gold can be used because gold can be hammered very thin, so it's only a few hundred atoms thick. And they're firing what to them was a very high energy alpha particle. This all needs evacuating, so there's no air in it, so the air doesn't interfere with the experimental results. And then you have a movable detector that you can move around, which I believe was a scintillating screen that Geiger and Marsden would move around here and then take readings. So they're looking for flashes of light. So what happens? Rutherford is doing this, sets up this experiment, asks his colleagues to undertake this experiment, and he is expecting that basically all the alpha particles will go pretty much straight through. He's not really expecting much else. In his mind, it's firing artillery cannon at tissue paper. So that's what he thinks he's doing in terms of the how thin this gold sheet is and how energetic these alpha particles are. So you could liken it to bullets firing these through. So they're expecting loads and loads to go straight through, and tens of thousands go straight through. But then as they move this around, they get some surprising results, and the surprising results are that one or two, a small proportion of the alpha particles are scattered through very large angles, and some are backscattered. That then leads to the eventual abandoning of the plum pudding model of the atom and the adoption of the nuclear model of the atom, which you're all familiar with. So the nuclear model of the atom, where you have a very dense, positively charged nucleus, and most of the atom is empty space. So this experiment very much leads to the discovery of the nucleus.